So I talked about this a little bit in section 1 where we needed to talk about issues with sampling. And that's what we're going to do in section 2. We're going to talk about bias. So samples are biased if they are systematically not representative of the desired population. So what that means is bias occurs when certain responses are systematically favored over others. Now, anytime you're performing a study or collecting a sample, you want to reduce bias as much as possible. There are a couple common ways, couple common types of bias. So one of them is called voluntary response bias. So this is specific to voluntary sampling method that we talked about in section 1. Voluntary response sampling has its own bias. So because a sample that is comprised entirely of volunteers or people who choose to participate, it's not going to be representative of your population. Because the people with the strongest opinions, no matter what direction that opinion is, are going to be the ones to respond. So like on a radio talk show, they ask listeners to call in with their opinions of making wearing masks in public spaces mandatory. People with strong opinions are going to be the ones to respond. Whenever you see a polling question that appears on the news, it says, we asked our viewers. That's voluntary response bias, which is why we don't use voluntary response as a sampling method. Another one is something called undercoverage. So this occurs when some groups in the population are left out of the process of choosing a sample. So the census, even though it attempts to gather information from everyone in the population, there's usually undercoverage. So something more specifically, because Latin American immigrants were fearful of government intrusion, they didn't return their census questionnaire during the 1990 census. So Latin American immigrants were left out of our census from 1990. So they were undercovered. There was undercoverage there. They were underrepresented. Right. And then we have just plain old non-response. Okay. So that occurs when an individual chosen for a sample can't be contacted or refuses to respond. So anything that's mailed out to you or emailed to you, right? Non-response is a big problem with those. So at any time you purchase something and they're like, fill out our survey, or you have someone come out and do work and they text you a survey afterwards. If you receive a survey in the mail, that's an example of non-response, because a lot of people they think it's spam, they don't answer it. So for an example, if an administration sent out 100 survey questions to a sample of parents in order to gauge their attitudes towards returning to school in 2020, and only 23 of them responded. So usually the amount of response out of the amount you sent out is so low that you can't really make good conclusions. Okay? So that leads us into something called response bias. So there's a lot of different types of response bias. And what that is it's bias caused by the behavior of the respondent or interviewer. So if someone that's interviewing, they're very rude, and your responses could be biased because you're feeling attacked or you're feeling they don't care. Same thing with the respondent. Their behavior can cause the interviewer to maybe, interpret their meaning wrong or just not take down their response. So then we have something called untruthful answers. which is another form of bias. It's exactly what it says. People give untruthful answers, and that can be for several reasons. The question could be sensitive, especially if it's not anonymous, and they're like, how often do you drink alcohol? People feel like giving an untruthful answer because they don't want to feel like they're being judged. There's also socially acceptable answers. Do you use corporal punishment with your children, like spanking and whatnot? Most parents, feel like they aren't going to be judged by society, are going to say no. And then there's interview bias. So, for example, here, 1 year after the Detroit race riots of 1967, interviewers asked a sample of Black residents in Detroit if they felt they could trust most white people, some white people, or none at all. When the interviewer was white, 35% answered most, and when the interviewer was Black, 7% answered most. So they were untruthful in their answer because the interviewer is white and they felt pressured to say that they trusted most white people. But when the interviewer was Black, they felt like they could be more truthful. They didn't feel as much pressure. We also have something called ignorance. So it's weird to think that ignorance can be bias, but it can. So people are going to give silly answers just so they won't appear like they know nothing about the subject. So there was a study where educators were asked how they would rank Princeton's undergraduate business program, and in every case it was rated among the top 10 departments in the country, even though Princeton doesn't offer an undergraduate business major. So people didn't want to seem ignorant about the fact that they didn't know about Princeton didn't have a business program, or that they didn't know anything about it. So if you don't know something, you can make up an answer to make it seem like you know what you were talking about. There's also something called lack of memory. So that's giving a wrong answer simply because you don't remember the correct answer. So, if teachers came around and asked you what your grade point average was, actual GPAs were found after that, and over 17% of the students reported a GPA that was 0.4 or more above their average, and about 2% reported GPA more than 0.4 below their actual GPA. So a lot of people inflated their GPAs, mainly because they couldn't remember and just thought that they, should be having a higher GPA. So even though it doesn't seem like it, lack of memory is an issue that can occur in sampling. There's also timing. Timing can have an impact. So when a survey is taken can have an impact on the answers. So in January, the NFL reported a poll that revealed football is the nation's favorite sport, which is when the Super Bowl happened. So a lot of people are really excited about football. If you're asked right after you take the ACT, did you like taking the ACT? Most people are probably going to say no, because it's a really long test. They just had to sit for a long time. They probably didn't like it. So when you ask something can have a huge impact on the answers. And then there's also phrasing. The way you word it can make a large difference in the results. So, for example, should the president have the line item vetoed to eliminate waste? 97% said yes. Should the president have the line item veto? 57% said yes. So notice how just adding that to eliminate waste, everyone was like, yeah, he should be able to veto eliminating waste. But if it was just straightforward line item veto, people were like, not so much. We're lastly going to talk about some errors that can happen when you're picking your sample. So there's two types of errors. There's the sampling error and there's a non-sampling error. So a sampling error is the difference between a sample result and the true population true population result. Okay, so this error results from chance variation. So I'm going to talk about what this means now. So the difference between a sample result and the actual true population result. So very rarely do you actually know true population results and a sample. Usually we use a sample to make a conclusion. We don't already know the population results, or else why would we be taking a sample? And when this difference happens, it's usually just from chance variation. It just happened because something about your sample was different. So a common example, you have 50 red and 50 green balls in a bag. So we know how many of each color in the bag. You mix them thoroughly and randomly sample 31 of the balls from the bag. 12 are red and 18 are green. So your ratio is a 2 to 3 ratio, is different than the true population ratio, which is 1 to 1. So this difference is due to sampling error. So virtually any experiment involving a sample is going to have a sampling error. So we minimize sampling error through some various statistical techniques, and the most obvious is to increase your sample size. So the larger the sample size you have, the lower chances you have of getting a sampling error. So you reduce variability by increasing your sample size. Then there's the non-sampling error, which occurs when the sample data are incorrectly collected, recorded, or analyzed. And this usually happens when the sample is selected in a non-random fashion. So we're not likely to see a lot of non-sampling errors in the examples we do because randomness is a huge part of sampling. You want to make sure randomness occurs somewhere. We might see a sampling error in some of the examples we look at because we didn't have a large enough sample size. So it's kind of like that example where you flip a coin. I could flip a coin 10 times. We know the ratio of getting heads to tails is 50-50, but I could flip a quarter 3 times in a row and get heads all 3 times. The 50-50 ratio comes from the fact that if I flipped a coin 200 times, I would roughly get 100 heads and 100 tails. It could be 90, it could be 99 and 101, but I'm going to get something that's pretty darn close to 50-50. But so small sample sizes are going to result more commonly in sampling error. So an example of a non-sampling error, so in order to gauge student opinion on a new grading policy, an administrator stands outside the library during a common time and asks a sample of 50 students if they agree with the new policy. And 25 out of 50 students agreed with the new policy. When the entire student body is asked, however, 30% were in favor and 70% were against. So the difference between the sample percentage of 50% and the true population percentage is due to non-sampling error because the sample was collected, so a lot of bias was involved. So convenience sampling. So if you're doing convenience sampling or voluntary response sampling, that's where you can have non-sampling errors occur a lot more frequently, is because those don't really involve any randomness to them. Because even systematic random sampling, there's randomness because you're asking like every 8th person or every 15th person. So there's randomness associated with that. Then obviously simple random sampling, stratified, and cluster all have randomness in them. So they're more likely to result in a sampling error. So if you have any questions about bias or even any questions about the different sampling methods we talked about in section 1, please let me know.